Vertical takeoff is the point in kinematics for projectiles just before the object becomes a projectile and flies freely through the space. This is the moment where the object pushes through a vertical displacement in order to go from an initial velocity of 0 to an initial velocity that we would call its takeoff speed. At this point, the acceleration is not equal to g due to the fact that the object is in contact with the ground, therefore generating a force that is upward, causing them to change their motion. Here's a reasonable example of takeoff. Suppose Mary generates an acceleration of 16 meters per second squared by bending her knees through a 52 centimeter displacement when she jumps. What's Mary's takeoff velocity? In this case, we're given the acceleration as a positive value of 16 meters per second squared, which based on the scenario of takeoff, we will take as going up and therefore up and positive. Her displacement that she moves through her legs is given as 52 centimeters, which before we can move on needs to be converted to 0.52 meters. Given these conditions, we know that her initial velocity is equal to 0 because every launching projectile must start at 0 before it begins to push off in order to be accelerated into the air. The final velocity is the question, also called the takeoff velocity at the top of the jump. The displacement now in proper SI units is 0.52 meters, and the acceleration is 16 meters per second squared. In this particular problem, we don't have the time it takes for this jump to occur, but we also don't need it in order to answer the question. There is an equation in kinematics that says v squared equals v naught squared plus 2ad, which we have in the past written as subscripts for vertical notation, such as vy squared equals vy naught squared plus 2g dy, but we're not using that this time, mainly because the problem occurs strictly vertical, but also because gravity is not acceleration. This is not a projectile problem. This is takeoff. In takeoff, we know that the final velocity squared is equal to 0 squared plus 2 times the upward acceleration of 16 through a displacement of 0.52 meters. The velocity squared is therefore equal to 16.64, making the upward velocity v the square root of this number, which is approximately 4 meters per second. Please keep in mind that taking the square root, this answer could be plus or minus 4, but in this context, due to the fact that the acceleration is up and the displacement is up, and both of those are positive numbers, this answer is positive 4 meters per second.